Okay, dear student, let us see what is there in this question. So, which is a correct unit of gravitational potential for gravitational potential? Okay, so my dear students, first of all, in these kind of questions, whenever you are talking about the units and all that, what you need is one particular formula in regards to gravitational potential. We will find that formula like, okay, this is the most suitable formula, or this is the formula that I know, this is the formula given in the data booklet in regards to gravitational potential, whatever formula that you can find in the data book regarding to gravitational potential, you can use that. And once we use that, we just need to substitute all of the values of the units for all of the physical quantities. Another point to be noted is that in these kind of questions, we are only interested in the seven fundamental units that we discuss in topic number one. Seven fundamental units, which are like length, mass, and time, and current, luminous intensity, then temperature, and then the amount of substance, which is mole. So these are the seven fundamental physical quantities, and we want to derive the unit of gravitational potential in the terms of these seven physical quantities. Okay, so we want to go for the formula first of all. So the formula that is first coming to my mind is this. This is basically the general definition of potential. It is the work done in bringing a unit mass from infinity to that point. So basically, when you bring that mass to some certain point in the gravitational field, you do work and you create potential energy. So the potential energy per unit mass is defined as gravitational potential. If you want to use any other formula, you can. Now, potential energy. So the unit is joule and the mass is kg. Now, when it comes to energy, it is joule. So you can use any formula, mgh, half mv square, any damn formula that you remember. In the case of energy, you can use as per the units are concerned. Okay, but I'm just keeping it like joule. So joule is also used for work. So you can use half mv square mgh. You can use work. Work is F into S, that is force into displacement. I believe this is the easiest of all. You can go for this also. You can go for this. I will take a couple of examples. So let us go for the F into S first of all. The unit is Newton and the S is meter. So Newton meter is the unit, like joule is a composite unit which can be divided into two, Newton meter. Now Newton meter and the unit will be Newton meter per kg. So clearly D is not our answer because meter is taken in the denominator here, meter raised to the power -1, but here meter is raised to power +1. So D is definitely wrong. Meter per second square is also wrong, by the way. Joule per kg doesn't make any sense, and A we have to see. Okay, now we are not interested in Newton anymore, so we have to break Newton. So F is equal to M into A. Newton can be written as kg meter per second square into meter divided by kg. So it becomes a meter square divided by second square. So clearly A is the answer. So I have used the formula F into S to compute the unit. You can go for mgh also, and let us do it with the help of mgh. Mg is the acceleration, which will be meter per second square, and h will be the meter. So kg meter square per second square is the mgh, which is energy. So directly we are reaching at this point. Now we need to divide it by kg further. So you divide it by kg further, again you are getting the same unit, and hence the answer is A. So my dear student, in this question, there are a couple of things that you need to note. Number one, obviously, what is gravitational potential? What are the units? How we have to find it? Number two, the procedure, like you can use any energy like weather potential energy, kinetic energy, work done. The only thing is that you are interested in joule, so you are interested in seven fundamental units, not in the composite units. Although these all units are SI, so don't get confused that joule is not an SI unit or Newton is not an SI unit. No, they are, but they are composite units. We have to break them down into the simpler units, the seven fundamental units. That is what we want to do. And this is how we do this question. Let us see what is the answer. For us, as answer is A. And according to the mark scheme, yes, the answer is A. So all the best.